Network address translation, otherwise known as NAT for short, is a pretty big topic. It's all about taking inside computers and translating them across some appliance as they communicate with outside computers. The concept of inside and outside is very important with NAT. A NAT can be a hardware appliance, but often is a function that exists in a router. The interface here is usually deemed inside, and the interface here is usually deemed outside. So you could configure like port 0 on this router to be NAT inside and connect it to a LAN, a VLAN, and then this outside could be connected out to the internet. So with all this in mind, there's a lot of different kinds of NAT. You have dynamic NAT, static NAT, dynamic NAT overload, which is also known as PAT or NAPT or NAT44. And then you also have CGNAT and LSN. Lots of terminology that goes with NAT. But I'm going to say right away, dynamic NAT overload is where NAT made its money. This is where you save IP addresses. You're overloading the address that you have on the outside, where all three of these computers can look like they're coming to the internet from this one IP address, and the way that they stay unique is it's translating ports, TCP and UDP ports. Originally, the internet was envisioned to be an end-to-end communications model from the perspective of IP addressing. But when you insert a network address translator in here, the end-to-end communications model is broken. Now you have IP identity from here to here and a separate IP identity from here to here. We'll cover some topologies and dig into what the inner workings of NAT looks like. But for now, I want to circle back on this. Static NAT and dynamic NAT are one-to-one NAT. What you have is one global IP address equals one internal inside IP address. So for every computer you have on the inside, you're going to need a unique global address to translate that to the outside. So there is no IP savings with regular dynamic or static NAT.